And I hope you're feeling the idea that it's really seriously getting time to produce. So, Ivy, if you could kill the lights, please. And I will go over these 4 quiz questions for you. This sequences stuff is not hard. It's weird. It's extremely weird. Where did Mary go?
Lessons.
Oh, she has lessons too? Okay. When you do really weird stuff, it takes a little while to get used to the weird stuff. But once you get used to it, it's not a big deal. And that's kind of how I feel that we are with some of the sequences. And as I look around, I feel like I haven't done enough work quizzing and assessing your knowledge of these sequence things. So you have this quiz, which will have all sequences on it, and the next couple of quizzes will each have 1 or 2 sequence questions. So, all right, without any further ado, let's go with the first question, which says, a recursively defined function has a first term equal to 10. Well, normally when we define something recursively, this is what we write for the first term is 10. A sub 1 is 10. But as you notice, all 4 of those choices don't write it like that. But I think you can understand when it says f of 1 equals that that's what they're trying to say, okay? So it has to be choice 1 or choice 3, because those are the 2 choices that have 10 as the first term. Now, which one out of choice 1 or 3 adds 4, because that's what it says, a common difference of 4. Choice 1. Now look, this is the most important thing that you can understand as to how you read this. On the one hand, yes, I understand that it says f of x equals f of x minus 1 plus 4. I get that. But context is everything. For example, there's a book written by a girl about your age, about the Battle of Gettysburg. I don't remember her name. I used to know it. I saw a special on it on TV. She was like 13 or 14 years old, and the battle literally happened outside her door. And to see her writing, not only the superior skills, but the emotion that she saw they literally took the soldiers and dragged them into her house and treated them, using her home as like a small little mini hospital, if you will. And then I believe later in the day, one of her relatives died. A stray bullet went through the window and killed her, and it was the only civilian who died during the Civil War. Now, if I was to have read the same story with the same account of things, and I didn't know it was the Civil War, it wouldn't have the same meaning. It would be a little bit different. But when you have this meaning, it's there. Another example that I can think of, I'm not preaching here, but there's a very famous story in the Bible about the prodigal son. And the prodigal son goes out and he parties his brains out and he leaves home, and he basically wastes all of his father's money. In fact, before he left, he loved his father so much that he looked at his dad and he said, listen, why don't you give me my inheritance now? What a way to talk to your father, right? Just give me the inheritance now, I'm out of here. He goes away and he spends it all on wine and women and a bunch of other stuff. And then one day he wakes up in a pig's trough. And he's got all of this pig garbage, crap, manure, everything all over him and everything else. And he realizes his life is ruined and he runs home. And when you talk to an American about this story, the American immediately identifies with the kid partying his brains out, because way too many people in America party their brains out. And they see it from that perspective. But if you carry the story just a little bit further, it talks about how the kid's father, every day he used to sit on the porch and he used to look and see if his son was coming home. And one day he sees him, and all it says is that the father ran to the son. And you and I would look at it like, okay, what's the big deal? Well, I talked to somebody from the Middle East about that story. And I said, what do you think about it? And he said, oh my God. I said, what do you mean? He said, in the Middle East, the father never runs. Never. The child runs to the father. The father is way too dignified. It is the burden is totally on the son to come back and so on. Yet, being an American, we never think like that. So the context of the story really, it speaks to someone from the Middle East in a way that it does not speak to someone in America. Well, when we look at this, there's a tendency to just read f of x is f of x minus 1 plus 4. And yes, I understand that verbatim, that's what it says. But that's not what it's really saying. If we put it in context, what this is really saying is the new term is the old term plus 4. The new term, the next term, is the previous term plus 4. That's what this is saying. And an understanding that that's what it's really saying to you opens up the rest of the quiz. And without that understanding, it makes the quiz extremely difficult. So let's now go to the second question, which says this. Again, if we read, f of n plus 1 equals negative 2 times f of n plus 3. No. The new term is negative 2 times the previous term. Look, the n plus 1 term always comes after the n term. The x minus 1 term always comes before the x term. So I would have a term, a term, a term. And if this term here is n, what's the term before n? N minus 1. What's the term after n? So I don't care if I use these two and I say the new term is the previous term, or if I use these two and I say the new term is the previous term and then whatever we're going to do to that. So I don't care if I write the new term is the previous term using x and x minus 1 or n plus 1 and n. The fact is n is always before n plus 1 and x minus 1 is always before x. So you have to understand new term, old term, previous term, prior term, etc. So the new term is negative 2 times the previous term plus 3. And then it goes a step further and it says f of 0 is 2. So what that's saying is that the first term is 2. So if I plug in a 2, what's negative 2? See, f of 0, so I'm going to plug it in here. What's negative 2 times 2? Negative 4. What's negative 4 plus 3? So we got 2, the 0 term is 2, the first term is negative 1. Now let's plug in the negative 1 to get the second term, right? This is the 0th term, this is the first term. I'm going to plug in the negative 1. What's negative 2 times negative 1? 2. What's 2 plus 3? 5. So there is my second term. It's 5. Okay? So all you're doing is following the rule to create the sequence. They're saying this is the 0th term, if you will, like the y-intercept. So then this is the first term, the second term. What would the third term be? Look it up, see if you can figure out the third term. Sammy? Okay, go ahead. Negative 7. Plug in the 5. What's negative 2 times 5? Negative 10. Negative 10 plus 3? Negative 7. Good. Tell me the next term. Who's got it? Emma? 17 is right. Plug in the negative 7. Negative 2 times negative 7 is 14, plus 3 is 17. Now, we use a very similar concept to get to the third question on the quiz, which says f of 1 is 3, f of n is negative 2 times f of n minus 1 plus 1. Now, what does this f of 1 equals 3 mean? What does that mean? First term's 3. Good. Now, I want to actually, it wants to know what f of 5 is, so it wants to know the fifth term. So that's the first term, second term, third term, fourth term, fifth term. Let's figure it out. Plugging in a 3. What's negative 2 times 3? Negative 6. Negative 6 plus 1? Negative 5. Good. What's the next term? 11, right? Plugging it in, negative 2 times negative 5 is 10. 10 plus 1 is 11. Nice. Plugging in a 4. Pardon me. Plugging in 11 for the fourth term. What's negative 2 times 11? Negative 22. Negative 22 plus 1? Negative 21. Good. Figure out the fifth term. Right? Negative 2 times negative 21 is 42, plus 1 is 43. So 43 is the correct answer. So here's what my opinion is. My opinion is that if you missed these questions, It's not because there's a lot of things you didn't know. It's because there's one thing you didn't know. And now that you know it, you should be able to do really well. Last but not least, which one of these is a rational number? Well, let's look at it from the opposite point of view. What's an irrational number? It's a number, first off, the easiest way to define it is it's not rational. So what's a rational number? No, not a whole number. A whole number is a whole number. A rational number is a rational number.
A number that ends.
Yeah, it can be written as a fraction. Okay? Now, taking that in terms of decimals, which is what you guys wanted to answer, it's a decimal that either stops or repeats. For example, 2.5, 7.0, or 7. 3.14 is a rational number. But the most famous irrational number in the history of the world is pi. Definitely. Pi never terminates, it never stops. It's not 3.14. Right, like you could hit the calculator and it would give you the screen filled up for the values of pi. But as I said before, I have a book in the back with either the first 10,000 or 100,000 decimal places of pi written out, and it will never stop and it will go on. Well, the most famous one is pi. The second most famous one is e, but you're not going to learn about e until you take Algebra 2 trig. And then there's any square root that you cannot figure out, like the square root of 7, square root of 3, square root of 2, square root of 101. Those are all irrational numbers. So knowing that, let's take a look at these choices here. Choice 1, is that made up of rational or irrational numbers? Irrational. What about choice 2? Rational. What is the square root of 4? 2. What's the square root of 3? Pardon me, square root of 9. And not that I'm going to ask you to do it. You could do it on your calculator if you wanted to, or if you remember how to work with fractions. But 1/2 plus 1/3 is equal to 5/6. And that is a number that can be written as a fraction. Therefore, it is a rational number. Okay? All right, so there's all the quiz stuff. And in my opinion, it's not that it's overly hard, but I think we were fuzzy on it. And now that we have a little bit better idea, I think we'll be better off tomorrow. Okay, let's talk about today's do it. And again, we're not doing a whole lot of new stuff. We're taking ideas that we already know and we're just applying them to yesterday word situations, the day before data situations. And today we have a graph and then we're going to have some sequences. The relationship between the length of one of the legs and feet of an animal and its walking speed can be modeled by the graph below. Notice the function applies not running speed. The animal with shorter legs than a giraffe, but it can run faster, whatever. However, in a walking race, the giraffe has a big advantage. A T-Rex's leg length was 20 feet. What was the T-Rex's speed in feet per second? So, if the T-Rex's leg length was 20 feet, I go up to here, and then I go over to here. What was his speed about? 20, 21, something like that. If they gave you choices on a test, they'd probably be like 17, 19, 21, 23. So, 21. Oh, that says 27. I'm sorry. I thought that said 22. Let me rearrange those choices. 15, 20, 25, 30. 25. Okay? So it'll be pretty obvious across from there. All right. Next. Bob's running again.
Oh, gosh.
Bob likes to run.
Bob, don't run.
Here's his wind sprints from the starting line to the far wall, back time t equals 0, blah, blah, blah. How far is Bob from the starting line at 2 seconds? So, this is 2 seconds. This is not 1. This is 2 here. So I go up to the graph. What do we got about? About 50. Good. 6.5 seconds. 6.5, which is a quarter of the way through, because half the way through would be 7. 85 maybe? Right? Sound reasonable?
Yep.
Okay, any questions about those? What do you think the point was behind giving you those first 2 questions? Yeah, I want you to be able to determine the y values. Remember, any point is always x, y. But that's also input, output. So when we're inputting, for instance, 6.5 seconds, the number it pairs up with over here, in this case approximately 85, is the output for that given time. Okay? A soccer coach is getting her students ready for the season by introducing them to high-intensity interval training. She presents the table below with a list of exercises and a high-intensity interval training, circuit training, length of time that must be spent on each exercise before the athlete gets a short time to rest. The rest times increase as the students complete more exercises in the circuit. Study the chart and answer the questions below. How long would the 10th exercise be? Blah, blah, blah. Okay, so it wants to know how long the 10th exercise would be. Figure it out. Notice they're not asking about the length of rest time here. They're asking about how long will the exercise time be. How's that working out?
It was good, but I ran out of rubber band. It's like
All right, we'll give you some of my extras.
a huge bag of rubber bands. Like I had like a box that's bigger than me.
All right, ready? Two ways to do this. We could blood and guts it.
No.
Yes.
6, 7, 8, 9, 10.
I don't like this one.
1.75, 2, 2.25, 2.5, 2.75.
Yeah, it's okay.
That's the blood and guts approach.
I like it.
And it's not too bad because you're only going out to 10. But if I said, what would the 77th exercise be?
I just can't make it.
That would be a little annoying. One way to do it also is to say it's the first term plus the difference times n minus 1, in this case 9, and 0.25 times 9 is 2.25. 0.5 plus that is 2.75.
Wow, that's very tough.
So, there you go. So you can do it either way.
Yay. Wait, is the blood and
I think
guts
it's very important to know how to do it the second way. Because you will see them ask, what's the 35th term? I just made your test for the test coming up. And I think I asked for the 45th term. So, okay. Now, what kind of sequence is the length of exercise sequence? What is it? Adding. What is the one that you add over and over again?
A and something.
Arithmetic.
Oh, there you go.
Okay. Now, is that the only question they ask about that?
No. Yeah.
All right, yeah, I think it is.
Yeah.
There's another one.
Now, this sequence, is it arithmetic or geometric?
Geometric.
Here's how you tell, ready? Are they adding the same thing over and over and over again? How much do I go up here?
Is it?
8. How much do I go up here? How much up here? 18. So it's definitely not arithmetic. Now let's check on geometric. Geometric has a common ratio. On your calculator, do 24 divided by 16.
It's a point.
1.5. Now do 36 divided by 24.
It's a 1.5.
1.5. Just check again. 54 divided by 36.
1.5.
So therefore, there's a common ratio, 1.5, so this is a geometric sequence. What's an analytic representation of it? Well, I could say a sub 1 is 16, and a sub n plus 1 is 3/2, which is 1.5, times a sub n. Now, to me, anytime I get an answer like that, I always like to plug it in and see if it checks. So let's check out and see if 81 works. Does 81 equal 3/2 times 54? Check it out and see.
It does.
What's that?
It does.
It does? Okay, very good. All right. Okay. Let's take a look here. A decorating consultant charges $50 for the first hour and $2 for each additional whole hour. How much does 1,000 hours cost? Go ahead. You better use the formula this time. So how do we do that formula again?
Wait, don't do it yet.
James?
I got the answer.
Oh, you don't, but you don't know how you did it.
I did.
All right, so tell me how you did it. The first term, 50 plus what?
2,
I'm sorry, 2 because of the common difference times what?
99.
999. Very good, because listen, the reason it's always n minus 1 here is you don't have to add the 2 to get the first term. You only add the 2 after the first term. So that's why it's n minus 1. That would be 1998, which would be 2048.
Yeah.
Very good. Okay. Preguntas? Questions? Okay, let's try the next one. The sequence below represents the area of a square whose side is the diagonal of a square, whose length is the diagonal of the square, and the integer side length n. So in other words, if this is 1 and this is 1, then the area, what does it say? Oh, does it say?
It's one.
It wants the length of the diagonal. Length of the diagonal,
Equal. Is one.
wait. Sequence below shows the area of a square whose side, okay, 1 times 1 is 1. Why are they putting 2 there? Hold it.
They don't know something in there, right?
Where's that from?
What?
Well, I'm not going to pay much attention to this. I'm going to pay attention to this.
Yeah.
I'm going from 2 to 8 to 18 to 32 to 50, and so on and so forth. We're not adding the same thing every time. If I look for the ratio, 8 divided by 2 is 4, 18. The ratio is changing every time. This is not, what's that?
They square it and then multiply it by 2.
They square it and then multiply it by 2. Okay.
So how do you, like, square root
Well,
stuff?
the bottom line though is it's not geometric and it's not arithmetic. Can you see that?
2, 4, 6, 8,
All right.
10.
So, what do they want to know here?
That is
They don't want to know anything. Oh, they want to know what's the area of the 100th square. Okay.
It is 9, 10,
Times 2.
But how do we?
Hold it.
4, times 6, times 8.
Well, listen. Alex just said the formula is 1 squared times 2, 2 squared times 2, 3 squared times 2, 4 squared times 2, 5 squared times 2. So if I'm going to do the 100th square, it's going to be 100 squared times 2. 100 squared is 1 followed by 4 zeros, which is 10,000, times 2 is going to be 20,000. Okay? All right. Any questions? All right, you are free to start your homework. All we're doing continuously for the last few days and the next few days, it's not like I'm teaching anything new. We're just applying what we already know.